So good afternoon everybody. I am Professor Shri Krishna Gosavi from Sverich Pandharpur, and today we will see the moment distribution method. Okay. So today we are going to see the moment distribution method. So introduction. Okay. I will introduce you to this moment. Okay. So basically we can say that the moment distribution method is the indirect, it is nothing but we are indirectly solving the slope and deflection equation. Okay. So the objective of the moment distribution method is, so from this method, the objective of this method is to find out fixed end moments. To find out fixed end moments. So let me explain with the example. Suppose now if this type of beam is there, this end is fixed. Suppose here the hinge is provided and somewhere here another support is provided. Okay. Now if you draw the free body diagram of this beam, then here horizontal reaction is there, vertical reaction is there, moment is there, here vertical reaction is present, here also the vertical reaction is present. Let it be point A, point B, and this is point C. Now if you see here at this point, this moment is present. This is nothing but the fixed end moment. This joint B, if we see the free body diagram of the joint, then suppose now if I draw here AB. Okay, so at A, here the moment is present, and at this point there will be a moment like this. Okay. At point B, here it is point A, and if I continue this point B and this is point C, so at this point B again, here will be moment. So I can show over here, this is the moment. So to calculate these fixed end moments, moment at A, moment at point B, we use moment distribution method. As we know, at C the hinge support is there, so there is hinge support, it doesn't have any capacity to restrain the moment, so therefore the moment at this point is 0. Instead of this hinge support, now suppose the fixed support was provided over here, then here also the moment will come into the picture. Okay, so basically what I want to say that to find out the fixed end moments, we use the moment distribution method, and after finding out the fixed end moments, we can find out the reactions, unknown reactions, and from those reactions and fixed end moments, we will draw shear force diagram and bending moment diagram of indeterminate structures. Okay. So some terms are there, some terminologies are there in the moment distribution method. So we will see those terms one by one. So first of all, what do you mean by fixed end moments? Okay. Fixed end moments. So I will tell you the meaning of fixed end moments. So fixed end moments is induced at the end of the member due to the applied load, considering the member to be fixed at both the ends. Okay, so the moment, I will write here, the moment induced, not in, at the ends of the member, due to applied loads considering the member to be fixed at both the ends. Considering the member to be fixed at both the ends. Okay, so fixed end moment means what? Now suppose suppose this end is fixed and here the simple support is provided. This is point B, this is point A. Here it is, this is point B and this is point A. So fixed end moments with what? If you observe at point A, fixed support is already provided, but if you see point B, there is no fixed support, there is a simple support. But the meaning of fixed end support is we have to consider both end fixed. Whatever may be the given type of loading, here the loading is given. Whatever may be the loading, it may be point load, UDL, UVL, what type of load acting on the beam, it doesn't matter. But you have to consider both the ends of the beam as a fixed end. So I will fix this end B also. Fix this end B also, B point, A point. And due to this applied load, some movement is generated here at this point A, some movement is generated here at this point B. This movement is called as MAB and this movement is called as MBA. This is anti-clockwise movement, so we will consider this moment as negative. This is clockwise movement, so we consider this moment as positive. So these two moments, MAB and MBA, these two are nothing but these are called as fixed end moments. FEM. Fixed end moments. Then the second terminology is carryover moment. Okay, we will see the second terminology, which is carryover moment. So now carryover moment. I will first explain you what is carryover moment. Okay. Now to explain this carryover moment, now suppose a beam is there. Suppose this end of the beam is fixed. This end of the beam is fixed and here the simple support is there. Imagine that this type of beam is there. Here it is point A, here it is point B. Now suppose here a moment M is applied. Here the moment M is applied. Okay, and this moment M is applied in such a way that the deflection or the deflected shape of the beam will be like this. If I draw tangent to this beam, this point here A, this angle will be theta. So this moment is applied in such a way that theta must be equal to 1. Then when the M moment is applied at this end here, the M moment is applied at this end here, A. So at B, the moment gets induced and a moment get induced, and that moment is, if this moment is M, then this moment is M by 2. This moment is M by 2. This M by 2 moment is nothing but this moment is called as carryover moment. Carryover moment. So now what is the meaning of carryover moment? This moment is not directly applied on the beam. This moment at point B is not directly applied on the beam. You have applied moment at point A. Due to the application of moment at point A, at point B a moment gets generated or induced. That moment is called as carryover moment. And this generated carryover moment, if this applied moment is M, then generated carryover moment is M by 2. So half of this moment, half of the total moment M. Now we will write the definition of this. It is defined as moment the moment induced at the fixed end. It is defined as the moment induced at the fixed end moment induced at fixed end and of the beam due to the action of, or we can say fixed end of the beam by the action of the moment proved by the action of the moment applied at other end of the beam. Okay. Now in the definition you will clearly understand that what is this. It is defined as the moment induced at fixed end. So this sentence is very important. Moment induced. The moment is getting generated. It is not applied. So moment is induced. So this is the induced moment. Okay. At fixed end. So at this end. By the by the action of the moment applied at other end. So moment applied. So applied moment is this. So I will give here name. This is your applied moment. Okay, this is your applied moment. Okay, so this is applied moment, and this moment is induced moment. Okay, so this moment is called as carryover moment. So next point comes into the consideration after the carryover moment is. I hope you will clear with this concept, carryover moment. In short, I will tell you, if I apply some moment at point A, that becomes my applied moment because I am applying that moment. Due to the moment applied at this end A, there will be some moment automatically gets generated at point B or get induced at point B. Okay, so due to the application of moment at A, there will be a generation of the moment at point B. So that generated moment at point B is known as carryover moment. Okay, so